Welcome to Spring LIB.
All right, so throughout this problem, we're gonna invoke energy conservation, obviously. And so in the first part, the trampoline artist jumps from 2 meters high, from 2 meters above the trampoline, and so the initial energy, initial E, will be equal to the final energy. So initially, you have the speed with which he jumps. So that's 1/2 mv naught squared. That's the kinetic energy, with speed being v naught. And the height from which he jumps, which is mg times y being the height. And that's equal to, all of that is converted to kinetic energy after the jump. So that's 1/2 mv1 squared. That's the velocity after the jump. So we want v1, right? And we observe here that each term in this equation has an m, so the masses all cancel out. And so v1 is what we want. So v1 squared is just v naught squared plus 2 times gy. I just multiplied both sides by 2. And so v1 becomes square root of v naught squared plus 2gy. Okay, and so that's v naught squared is 4.5 meters per second, quantity squared, plus 2g is 9.8 meters per second, and y is 2 meters. That's how where he jumps from, and so this comes out to be 7.7 meters per second. That's v1. All right, in part B, we also use energy conservation. Here, we're saying that all of the KE, so at part A, you have all of the previous energy converted to kinetic energy. So we're saying that all of the kinetic energy will be converted to elastic potential energy. Let's call it EPE. And so you have 1/2 mv1 squared as before, and this is equal to 1/2 kx squared. That's the elastic potential energy, and k being the spin constant, and x the length we want. That's the length to which it stretches. So the 1/2s cancel, and you get that x is k. X is the square root of mv1 squared over k, and so that's mass is 72 kilograms. v1 squared is 7.7 meters per second quantity squared over k, which is 5.8 times 10 to the 4, so 58,000 newtons per meters. So these are all in SI units. And so you work that out and you get 0.27 meters is how much the spring stretched. And that's it.